Okay, so today we're going to be going through the 2020 HSC physics paper, question 24. And in this question, it's going to be related to projectile motion again, and that's what we're going to look at. Here we have a little stimulus that portrays a projectile motion. Now, in this case, it's the scenario we're looking at is the launch height and the landing height is the same. So that's the scenario we're looking at here. The range of the projectile is 130 meters. The maximum height we'd reach, if we look at this bit here, is 44 meters. And we also know at 44 meters, the time taken to reach that point is 3 seconds. The time it takes to reach 130 meters is 6 seconds. The question's asking for you to find the initial velocity. Now, we have displacements, but we do not have the initial horizontal and we do not have the initial vertical. So that's what we need to find out. So to start off, the first one I'm going to do is the initial horizontal because that's pretty easy to do. 130 equals to ux times 6. So ux is 130 over 6. And if I round that off to 3 significant figures, my answer would be 21.7 meters per second. Okay, the next one I'm going to do is uy. Now I know what the displacement is, and I also know the time. So what's known to me? Uy or sy is known to me, ty is known to me, and also acceleration due to gravity is also known to me. So what I'm going to do is there's actually two formulas you can use. You can either use this one here, or you can use this one here. Because as you know, when we reach maximum height, the velocity at that point would be equal to 0. So you can use either of those two equations. I'm going to use this one here. So Vy squared equals to Uy squared plus 2a s squared. So V is 0. We know that's still squared. 2 times minus 9.8 times the displacement, which is 44 going up. Well, there's no squared there, no squared there. So I move the equation over. So I've subtracted both sides by this value. So it's minus 2 minus 9.8 bracket 44 equals uy squared, meaning by if I want to get rid of this square, I square root both sides. And that leaves me a value in 3 significant figures again of 29.4 meters per second. What I need to do now is to solve for these two vectors to find the resultant component. So I've kind of ran out of space for myself, but I'm just going to use this little bit here to work it out. So the current scenario we have is we're trying to find the resultant. We already know what ux is, and we already know what uy is. I need to find the resultant velocity and the angle. So the first thing, the launch velocity, I can solve this through Pythagoras theorem. 21.7 squared plus 29.4 squared, and that equals to 3 sig figs again, 36.5 meters per second. Okay, the last bit is theta, and obviously as I drew there, theta would be tan ratio, so tan inverse of 29.4 over 21.7. And so theta would be approximately 54 degrees above the horizontal. Okay, so we found our launch speed, or velocity, and we also found the angle with which it was launched. So that's how you do the question.